Okay, so let's go over trigonometric functions. Trigonometric functions, there are three pretty basic ones. They are the sine, the cosine, and the tangent. Okay, now these three are the three most basic ones. There's three that go along with these, but we'll get into that later. These are abbreviated with SIN, COS, and TAN. And the way a lot of people remember what these stand for is by the acronym SOHCAHTOA. And people made a lot of stories about them. You found how to remember it, and you can look those up on the internet. But so these are the ways to remember what sine, cosine, and tangent represent. And the thing that I think a lot of people struggle with is understanding that sine, cosine, and tangent are actually ratios. They come from similar triangles that triangles with a right angle and another certain angle are all going to be similar no matter what size they are. That comes from the angle-angle similarity postulate or theorem, I can't remember. So whenever you're taking a trig function, it's always going to be of an angle. So let's just say for now, we're taking the sine of theta, the cosine of theta, and the tangent of theta. Theta is just a Greek letter, same as if you used x. We could use x, but generally x is used for a missing side. Theta is used for a missing angle. And in each of these cases, we have neither of them, neither sides nor angles, because we're just defining things. So this SO down here represents that sine is the ratio of the opposite side divided by the hypotenuse side. And I guess we should go over what sides are what. So here we have a triangle, and it doesn't really matter. No special triangle, it is just a triangle. Well, not special other than it is a right triangle. It is not a special right triangle. So this is going to be our reference angle theta. It is a variable. It can be any angle we want. Now, the first thing that you need to know is that this side is always going to be the hypotenuse. That should be the first one that you make note of. The hypotenuse is always opposite the right angle. So I'm going to mark that with an H. Now, the side opposite the reference angle, remember theta is our reference angle. We call it a reference angle because that's the angle that we're going off of. We also have this angle up here. We can just call it alpha, just for something else. And if we used alpha as our reference angle, some of them would change, but we're not going to get into that. So if theta is our reference angle, the side opposite theta is going to be the opposite side. And the side right next to theta is going to be the adjacent side. Using this knowledge, we're going to go back here. The sine of theta, based from SOHCAHTOA, the sine is the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse. And the tangent is the opposite over adjacent. So let's go back to this picture, and let's use some color, just because color is more fun. So if I'm talking about the sine of theta, it's going to equal the opposite over the hypotenuse. Opposite over hypotenuse. The cosine of theta is going to be the adjacent over the hypotenuse, and the tangent of theta is going to be the opposite over the adjacent. And these all come from SOHCAHTOA, which I will rewrite. SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. It is not uncommon for people to write these on tests or homework or pretty much anywhere. This is a very, very important acronym to help you remember what these represent. So, like I was saying, some people I find it hard to remember that the sine, the cosine, and the tangent actually represent ratios. And these ratios are what help us solve right triangles. So let's try one out. So let's say we have some triangle, and this triangle is again nothing special other than the fact that it is a right triangle. This angle down here, we can call it, doesn't matter, let's say 35 degrees. Now, if this side's 35 degrees and I know that the hypotenuse is 6, and let's say I want to find all the other parts of the triangle. There are many, many ways to do this. So I want to find, first of all, let's start naming some things. Let's call this angle up here alpha. Let's call this side, I don't want to use O because that can be confused with 0, so let's call it y. And let's call this side z. No, let's call it x. X is better. Okay, so these are the three things that we need to find. We need to find the angle alpha and the sides x and y. Now, let's start with x because I feel that would be the logical place to start. And my marker's already on blue. So I am given the angle 35 and the hypotenuse of 6. What I would also like to write down is that x is the adjacent side. Y, I'm going to write my O like that, is the opposite side. And 6 is the hypotenuse. Because x is adjacent to the 35-degree angle, y is opposite to the 35-degree angle, and 6 is opposite the right angle. 6 is opposite the right angle. That should be the first thing you do. I didn't do that. But that just gets it out of the way because some people confuse the hypotenuse and the adjacent angle. So, I'm sorry, the adjacent side. So let's talk about finding x. Now, x is the adjacent side, and I have the hypotenuse. So I have the adjacent, or I want to find the adjacent, and I have the hypotenuse. The question is, which ratio, sine, cosine, or tangent, uses adjacent and hypotenuse? Well, this is the cosine. So the cosine of theta is the adjacent over the hypotenuse. Now remember, the cosine of theta is a ratio. So what we're doing is we're solving a proportion here. Because I know that theta, the angle that I'm looking at, is 35. So the cosine of 35 equals the adjacent is what I'm looking for. And the hypotenuse is 6. So we decided to call the adjacent side x. So now all I have to do, cosine of 35 is a number, and there's really no other way to find this out other than putting it in a calculator. So I put cosine of 35 in my calculator, and I get 0.8192 something, or that's rounded to 4 decimal places. So this equals x over 6. Now my goal is to get x by itself. So what I do is I multiply each side by 6. In doing so, the 6's cancel out on the right side, and I just take the number that I got for cosine of 35 and I multiply it by 6. And in this case, it is 4.9149. That is x. So I have one side solved for. This equals 4.9149. And the next side we could solve for is the opposite side. And in this case, we could use either the adjacent or the hypotenuse in our calculations. However, it would be better to use the hypotenuse because 6 is an exact number. The value we got for x is rounded 4 decimal places, so it's not exact. However, the hypotenuse is 6, so let's stick with that. So we're using the opposite and the hypotenuse. So the question is, again, which trig function do we use in order to, or which trig function uses the opposite and the hypotenuse? And this would be the sine. So in this case, we're taking the sine of theta, which is opposite over hypotenuse. Now, I know that my theta is 35 because that's my reference angle. and I know that my opposite side is what I'm looking for. That is y. My hypotenuse is 6. Now to shorten up some steps, instead of finding what sine of 35 is, I'm going to straight off the bat and multiply by 6 to both sides, so that these cancel out, because my goal is to get y by itself. So now I have y by itself. So in my calculator, I type 6 times the sine of 35, and this time I get 3.4415. And that is my y value, 3.4415. Now I have all three sides, and I have two of the angles, one being 35 degrees, one being 90 degrees. And I know that the sum of all angles in a triangle have to add up to 180 degrees. So 90 of the degrees are accounted for in a 90-degree angle. So I have 90 left over. So if I take 90 minus the 35 degrees, I am left with 55. So this angle up here has to be 55 degrees. And this makes sense, because if you've heard of it before, the law of sine says that the biggest angle will be opposite the biggest side, the smallest angle will be opposite the smallest side. This is true because the biggest angle is 90 degrees and it's opposite the 6th length side. 55 is the medium and it's opposite the medium side, which is side x, the 4.9149. And 35 is the smallest angle, which is opposite the smallest side. And we'll get into those laws later, the law of sines and law of cosines. But let's do another example. So again, we have a triangle. This triangle is at the top of the page. And we'll use a different angle this time. Let's say our angle given this time is, we'll say 75 degrees. And this is a right triangle, so that's 90 degrees. Let's say this time that this side over here is 6. So in this case, I am still looking for this alpha. I don't know what I'm trying to draw there. Still looking for this alpha, that degree, that angle measure. Now this time, I want to find this side, we'll call it z, and we'll keep this side x. Except I want that as a different color. So this side x, being blue again. Now let's label what sides we're dealing with. Z, since it is opposite the right angle, is going to be our hypotenuse. And keeping colors consistent, we're going to say that with green. So Z is the hypotenuse. The 6 is opposite the 75 degrees, so 6 is going to be the opposite side. And x is going to be the adjacent side, since it is right next to the 75 degrees. Here are the 1, 2, 3 things that we need to solve for. And this time, let's start with the angle alpha. Now, this angle alpha, again, all we have to do, since a triangle is, the sum of the angles of a triangle is 180 degrees, I just take 180 minus the 90 degrees that I have, plus the 75 degrees. So the 90 and the 75 together give us, give me a second to think, 165. So that means 180 minus the 165 degrees that are already accounted for equals 15. So this angle alpha up here has to be 15 degrees. Now that we have both angles, we need to think, well, which one's our reference angle? Well, we already labeled our sides such that z is the hypotenuse and x is the adjacent. So since x is adjacent to 75, we have to stick with that angle measure. And so this time, we have only, again, we'll start with x. It doesn't really matter, but we'll do that. Since we already have the opposite side, and we want to find the adjacent side, we're dealing with opposite over adjacent. And the question is, which trig function is the opposite over the adjacent? Well, that happens to be the tangent. So the tangent of some theta is the opposite over the adjacent. Now, we know our theta to be 75. We know our opposite side to be 6. And we know our adjacent side to be what we're looking for, which is x. Now, if I multiply both sides by x, this is exactly why I make my x's fancy so they don't get confused with time signs. Multiply both sides by x and then divide both sides by the tangent of 75. The x's cancel out on the right side, and the tangent 75 cancels out on the left side. Remember, tangent of 75 is a number in and of itself. It is a decimal number. It is a ratio. You can't just cancel out the 75, and you can't just cancel out the tangent. The tangent of 75 is the whole number. It is one entity. So now I'm left with x equals 6 divided by the tangent of 75. And, again, the only way to do this is with the calculator. So I'm going to go in and I'm going to say 6 divided by the tangent of 75, which gives me 1.6077. And the reason you don't see me doing this on the calculator in the computer is because calculators on computers are a little bit strange with how you have to input things. And it's easier to use a scientific calculator. If you're using a scientific calculator, you just put it in right as you say it. This is 6 divided by the tangent of 75. So that's exactly what I put in the calculator, 6 divided by the tangent of 75. So this tells us that side x is 1.6077. And so now all we have to do is find side z. Now again, I could use either the adjacent or the opposite. However, I would recommend using the opposite since the opposite is the exact number and the adjacent is something that's rounded. So in this case, to find the hypotenuse, I'm taking the opposite divided by the hypotenuse. And this is going to equal, we need to figure out which trig function to use. Well, since we're dealing with the opposite and the hypotenuse, we are going to use the sine. So the sine of this 75 degrees equals the opposite over the hypotenuse. And I put 75 instead of theta because we already know that is our reference angle. So in this case, this will be the sine of 75 equals the opposite side, which is 6, divided by the hypotenuse, which is z. And this is a fancy O, not a 0. Okay, so now same thing. Now there's, instead of multiplying both sides by z and then dividing both sides by 75, there's kind of a little shortcut you can do that you can only do as long as you understand this process. That multiplying both sides by x and dividing both sides by the tangent of 75 yields x equals 6 divided by the tangent of 75. In this case, where we're talking about z, all I really need to do is just switch these positions. If the variable is in the denominator, all you need to do is switch their positions, the sine or the trig function and the variable, only if the variable is in the denominator. If the variable is in the numerator, as in both of these cases, all you have to do is multiply both sides by the denominator and you're good to go. Again, that's not the case here, so we just switch the places and we end up with z equals 6 divided by the sine of 75. So go back to the calculator and type in 6 divided by the sine of 75 and you'll get 6.2117. 6.2117. So this tells us, and this makes sense, because the biggest side is opposite the 90-degree angle. It's the hypotenuse. It is the biggest one because it's 6.2. The smallest one is opposite the 15-degree angle, and it's 1.6. You can see the drastic differences between the two legs. This triangle is not drawn to scale, and none of my triangles will be. And the 6, which is in the middle, is opposite the medium-sized angle, which is a 75. So this makes sense. These are good answers, and let's move on. So I'll be doing all the drawing now. Draw another triangle, And this is a bad triangle. Let's try this again. Base, 2 legs, hypotenuse, right angle. Let's start with the top angle this time. We'll start with a different angle. So let's say this angle up top is, we'll call it 25 degrees. We'll just say 20. 20 is a good number. This is a 20-degree angle, and then this side will be my alpha. This will still be z, and it's going to be the hypotenuse because it is opposite the right angle. This side down here will be our x, which should be in blue because different colors are fun. So since it is opposite the angle, this is going to be the opposite side now. Notice what happened. Since our reference angle changed to the angle up here, then that changes how how we look at the triangle. So instead of the base of the triangle being the adjacent side, it is now the opposite side because the reference angle changed. It all is based off of the reference angle. So since x is opposite the 20-degree angle that we know, then it is the opposite side. And once again, let's put, and let's make this side be 6. And this is going to be the adjacent angle, the adjacent side this time. I'm sorry, the adjacent side. So since alpha is the easiest one to find, let's find that one first. And so again, we're going to take the total 180 degrees in a triangle and subtract the 2 angles that we know, which are 20 and 90. So 20 and 90 is 110, which gives us 180 minus 110 should be 70, which makes sense because 70 and 20 equals 90. So there, we are 1/3 of the way down already. Next, let's find z, which will utilize the adjacent and the hypotenuse. So we have to look back what trig function utilizes the adjacent and the hypotenuse, and that is going to be the cosine. So the cosine of our theta equals the adjacent over the hypotenuse. And remember, so we're doing the cosine of some angle. Remember what our reference angle is. Our reference angle is not the 70, it's the 20. We started out with the 20, we labeled our sides as opposite, adjacent, and hypotenuse from the 20, so we have to say the cosine of 20 this time. So my adjacent side is 6, and my hypotenuse is what we're looking for, which is our z. And remember, when the variable is in the denominator, then all you have to do is switch places. So z is going to equal 6 divided by the cosine of 20. And you have to trust a calculator and type in 6 divided by the cosine of 20, and you will get z equaling 6.3851. 6.3851. All right, so that's the hypotenuse, and we are 2/3 of the way done. So now all we have to do is find the opposite side. Now the opposite side, let's stick with using the adjacent and the opposite. And so if we are using the opposites and the adjacent, I write them very specifically because the tangent ratio is going to be the opposite over the adjacent, not the adjacent over opposite. Order is also very important. For instance, if you're intrigued, you should understand this, that the sine of 30 is 1/2. It's 1/2. The cosine of 30 is the square root of 3/2. None of these values are going to be greater than 1. If you take the reciprocal of them, they will be greater than 1, and that is different trig values. So order is very important in how you write these in. So the tangent of our reference angle, which is again 20, not 70. The opposite side is what we're looking for, which is the x, and the adjacent side is what we have, which is 6. So now the variable is in the numerator and the constant is in the denominator. So if I multiply by 6 to both sides, they cancel out on the right, and I'm left with 6 times the tangent of 20 is our x, which, when put in the calculator, yields 2.1838. 2.1838 is what my calculator says. Just checking. 1838. And once again, our longest side being the hypotenuse is opposite the biggest angle. The smallest side being the opposite side is opposite the smallest angle. Okay, so there is an example of a triangle with each of the sides given. First one I gave you the hypotenuse, and we found the missing angle in the other two sides. Next one I gave you the opposite side, and we found the two missing sides in the angle. And the last one I gave you the adjacent side, and we found the two missing sides in the angle. However, there's one more instance that could happen. And this instance is if you are given, instead of an angle and a side, what if you are just given two angles or two sides? If you are given two sides, then let's say that the hypotenuse is 4. We'll do a happy triangle. A Pythagorean triple. Let's say the hypotenuse is 5. One of the legs is 4, and the other leg is 3. This does make a right triangle. It is a Pythagorean triple. And our job today is to figure out what angles alpha and what angle theta, what they are. And of course, this is given to be a right triangle because trig functions do not work in any triangle other than a right triangle. So that has to be given. And if you're not given a right triangle, you can create an altitude from an angle to its opposite side that is perpendicular, and then you have created a right triangle. In fact, we'll just do an example like that after this. So our goal is to figure out what these angles are. And I'm going to do each of these in 3 different ways. So let's label what sides are what. For alpha, 5 is going to be the hypotenuse, 3 is going to be the opposite side, and 4 is going to be the adjacent side. For theta, 5 is still going to be the hypotenuse, 3 is now going to be the adjacent side, and 4 is now going to be the opposite side. Because whichever reference angle you use changes what these sides are. So this is very important. So let's figure out alpha first. So we could use any of the 3 combinations. We could use the opposite over the hypotenuse, we could use adjacent over the hypotenuse, or we could use opposite over adjacent. So the opposite over the hypotenuse is the sine of alpha. Adjacent over hypotenuse is the cosine of alpha, and the opposite over the adjacent is the tangent of alpha. Now, in order to figure these out, and I should have spaced these better, but I can still break it up, maybe? Yes, I can. So bring these down, and bring that down, and bring that down, and bring it down some more, for good measure. Okay, so when we were solving these equations, and this one's the best example, I think, because when we solved for tangent, we had to multiply by 6 because there was a 6 in the denominator. So we had on the right side x divided by 6. So the opposite of division is multiplication. So we multiplied by 6. And long story short, the huge, big, ugly way to figure the tangent out in this one is that the variable was in the denominator, so it was 6 divided by x, so we multiply both sides by x, and then it was x times tangent of 75, so we divided by the tangent of 75 to both sides. So trig functions have their own versions of inverses. But it is a little different, because there's no, it's not just switch a sign here. We're actually switching places of the trig function, and we're doing the inverse of it. Now, the way this is written is instead of writing the sine of an angle, we are now going to do the sine inverse of the opposite side divided by the hypotenuse. Now, the opposite for alpha, which is the red one, the opposite is 3. The hypotenuse is, in all cases, going to be 5. Now, this button is on your calculator, and it's generally, in this case, it will be above sine. So you push your second or your shift button, and it will come up with a sign, little -1, and you type in 3 divided by 5. You don't need to put a fraction in there. If you just type 3 divided by 5, your calculator will understand what to do. And it says that the sine inverse of 3/5 is 36.8699. And this is something else that's a little bit weird. They have the sign to the negative first power. Now, some of you may be confused with this because this is an exponent. It's not an inverse function. Well, that's the thing, that this is more terminology than actual operations. So this is called the sine inverse, and when you take the sine inverse of something, you take the sine inverse of the ratio. You take the sine of an angle and the sine inverse of the angle's ratio. So sine inverse of the ratio. So now to find the cosine of alpha, we're going to do, again, the cosine inverse of the adjacent side of alpha, which is 4, and the hypotenuse, we said, is always 5. So we're going to take the cosine inverse in your calculator of 4 divided by 5, and when you put that in, it's the same answer, 36.8699. Guess what? It's going to be the same answer for tangent 2. The opposite side, we're going to take the tangent inverse of the opposite side, which is 3, over the adjacent side, which is 4. That's going to equal alpha. Should have written the alphas in. And alpha is going to be the same thing, 36.8699. So what this shows us is that it doesn't matter which pair of sides we use, that we are always going to find alpha to be 36.8699. Now we want to find theta. And I'm only going to do 1, and for some reason tangent's my favorite, so we're going to use tangent. So the tangent of this theta is going to equal the opposite side over the adjacent side. Now, for tangent theta, the opposite side is 4, and the adjacent side is 3. For theta, for the green labels that we have. Now that we have tangent, we can find the tangent inverse. The tangent inverse of 4/3 equals theta. And this goes into your calculator, so shift tangent, or second tangent, the words above the button for tangent, should be tangent inverse. So we type in tangent inverse, and I type 4 divided by 3, which didn't type incorrectly. And this gives me that theta equals 53.1301. So this one is 53.1301. Now, another way you could do this, you could have done this, you could have used sine or cosine, of course. However, you could also take the 90 degrees left over from the triangle after we have already taken into consideration this 90 degrees. And if you take the 90 minus our alpha, which was 36.8699, you also get 53.1301. That way's a little bit easier. In fact, it's a lot easier, instead of figuring out all the trig stuff for it. So let's do another triangle, just real quick. to show you how you can figure these things out. So let's say that this is not a right triangle. Well, what I can do is, once I get everything situated, I can drop an altitude from the top angle, and I can say, since I created this altitude, I can make it in such a way that it is a right angle. And if I'm given this angle and this side, which will now be the hypotenuse, let's say that this angle was 27. Sure, why not? That angle is 27 degrees and the hypotenuse is 8. I can find everything in this triangle. I can find this missing angle by 90 minus 27. I can find, this is, I'll just write it in 90 minus 27. The other legs, since this is the adjacent side, this is going to be the cosine of 27 equals the adjacent side over the hypotenuse 8. And the vertical leg, the altitude that we just drew, is going to be the sine of 27 is the opposite side divided by 8. So we can do everything in that triangle. However, we have nothing for the other half of the triangle, so there would have to be something given there, like this angle, which let's say is 36 degrees. And it's the same process, and this video is getting long, so I'm going to stop there. There you go. It's the exact same process to find the rest of the pieces of that triangle. 90 minus 36 for the missing angle up top. I guess I'm going to keep going anyway. And we already know what this opposite side is. You can't see where I'm pointing. What this opposite side is. So once we have a number for that, we can use it in calculations to find the other two missing sides. And we can call them, it doesn't matter, Z and X. So there is a very brief overview of solving triangles using trig properties.